Good morning, afternoon, whatever time you're watching this. We are going to be going over the Quizizz review for Unit 3, Math 3. So let's get right into it. The first question, what function has a remainder of 19 when divided by x plus 2? Remainder of 19. So I just use substitution on that. Plug in -2. Always switch the sign. So let's do that. Pause the recording, try it on your own. All right. So I got my -2 plugged into all four of my functions. And as you can see, the one that gives me 19 is x squared minus 4x plus 7. So it's going to be this one. Is x minus 2 a factor of the polynomial? Again, plug it in. Plug in 2 this time. Factors give you a remainder of 0. So take a minute to plug it in, see what you get, and then unpause the video. Okay, I've taken a moment to plug it in. I plugged in +2 into this function. I get -16. That's my remainder. Since it's not 0, it's not going to be a factor. Next question. When the polynomial 2x to the fourth minus 9x squared plus 10x minus 20 is divided by x plus 3, what's the remainder? Type in the numeric value. Again, plug it in. So once again, pause the video, try it on your own. Okay, I've plugged in -3 because it's x plus 3. I got 31. So my remainder is 31. Next question. For the polynomial function, what is the sum of all the zeros? We want to graph it or get the zeros from here. I can tell you right now, the zeros are going to be whatever these equations solve for. So this one's going to be 2, -1, and 5 divided by 2 is 2.5. So the sum means add 2 plus -1 plus 2.5 is 1 plus 2.5 is 3.5. You can also get the zeros in the calculator. You can graph it. And I have graphed it. Zeros are going to be where it hits the x-axis. -1, 2, and 2.5. So add them together and you get 3.5. Sum. Next question. The table pictured here shows the values of two polynomial functions, p of x and q of x at various values of q. Which statement best describes when p of x equals q of x? Okay, so to visualize what's going on here, when they equal each other, that means where the graphs cross. And if you were to plot these points, you would see that the p of x, which I have in blue, kind of follows a line. You know, at 4, it's 23. At 5, it's 27. Notice that it's bigger, but then right at 5, the q of x is bigger, so that overtakes it. So right around here is when they intersect. And that's going to be between 4 and 5. So next question. Graph the polynomial. Which of the following end behaviors is true? Well, let me go ahead and graph that. Okay, so when you graph the polynomial, it opens up to the left and down to the right. So the way you write that, there's a couple different ways to write that. Since that's p of x, that's like your y. So we say as x goes to the left, which is -infinity, y goes up, so that's going to be infinity. So that's your left end behavior. And then your right, since it goes down, you say as x goes to infinity, that's on the right side, you say p of x, that's your y, and that goes down, so negative infinity. So left, up, right, down. Next question. A graph has the following characteristics. Which function represents this graph? Now I can tell you right now, it says that y-intercept is at 0, -6. And that's going to end with -6. So can't be those two. It also has end behavior that's going to be, that's f of x, that's y. So that's going to be up, and that's left, because that's negative infinity for x, and down, right. So we want it to look like, kind of like the last one, up on the left, down on the right. And it needs to cross the x-axis at -1, 2, and 3. So we're looking for something like that. So I'm going to graph a couple. Okay, I've only graphed these last two because they end in -6 for my y-intercept. And notice that this one has the right end behaviors. On the left side it goes up, on the right side it goes down. And it has the zeros -1, 2, and 3. This one crosses at the opposite zeros, -3, -2, and 1, and its end behavior is flipped. So it's going to be this one here. Okay, number 8. On which interval is the function 2x squared minus 18x plus 42 increasing? Increasing is going up as it goes to the right. Let's graph it. Okay, so this is going to go up, starting at x is 4.5, going up. So anything from 4.5 to the right is increasing. Always use the x values. So 4.5 to infinity is increasing. Number 9, which function increases on the interval negative infinity to 1 but decreases on the interval 1 to infinity? So it's going to look so right at 1, it's going to, wherever that is, it's going to go up and then go down. So we're looking for something like that. Let's graph them. All right, in this graph here we have, I'm going to turn these all off and just look at one at a time. This one's decreasing through the entire thing. This one's increasing through the entire thing. This one down here, it starts off decreasing, then starts increasing. So it's going to be the one with the negative out front. Remember, the negative reflects it. So it's increasing and then decreasing. And of course, that point is 1, that it stops and turns around. So it is going to be this one. Number 10. Let's see, what are the zeros for this polynomial? You can get this by hand. This is going to be -3, +5. And if you solve this for 0, you get 3 divided by 2. Oops, 3 divided by 2, which is 1.5. So it should be those 3, -3, 5, and 1.5. You can also graph it and get them from there too, but I'm not going to do that. All right, what's the end behavior? Let's graph it again. All right, this graph opens down on the, oh, I can't see it, opens down on the left and the right side. So it's going to have negative infinity for both your y's. So it's going to be that one. 12. What points does the graph of the polynomial intersect the x-axis? Those are zeros. Find the zeros. It's not in factored form, so we can't just solve those. So we actually got to graph that. All right. If we graph those, we get Negative 2, 1, and 4. Negative 2, 1, and 4. All right, 13. Multiply. Let's see, that's going to be 6x to the third. That's going to be 10x squared. And that's negative 14x. That's negative 15x squared. That's negative 25x. And then that's positive 35. So 10 minus 15 is negative 5x squared. And negative 14 and negative 25 is negative 39x. So that's what we want. 14. How many terms? I mean, 1, 2, 3. And that's it.